For the one sample t-test, we calculate t by using x bar minus the population mean divided by the standard deviation of the sample divided by the square root of the sample size. So how do we get x bar? X bar is the average of all the scores. So we can calculate that. Formula for the average would be here. Average is calculate the average of B2 through B21. So you use this formula and enter the area that you want the average to be calculated from. The fast way to get the standard deviation is using the standard deviation formula. So equals standard deviation and then again say the area of all the values. So it's the same area. Here what I showed is the long way to do it, right? Step by step. This is what Excel does in the background, right? We calculate x bar is the sample mean. This is x minus x bar is the distance of the individual score to the sample mean. So this, if we square this difference, we get only positive value plus the distances are reinforced. So values above 1 become bigger. 1 times 1 stays 1, and values below 1 become smaller. Right? That way we emphasize larger differences and we minimize smaller differences. Then we add all these squared distances up. That's the sum of the squared deviations, and we divide that by n minus 1. So we divide the sum of squared differences by n minus 1. Here it's 20 minus 1, 19. That gives us the variance. If we take the square root of the variance, we get the standard deviation. Standard deviation squared gives us the variance. Alright, so here you see exactly every step, but the fast way would be to use the standard deviation formula. So now we have all the components that we need to plug into this formula except the value of the population. Right, so we plug all these values in, the x bar, the mean of the sample, the standard deviation of the sample, and the sample size. Note it's n, not n minus 1. Right? We used n minus 1 to calculate standard deviation, but for the t-value here we use the n. Now the population value, usually you might get that either it's indicated, like somebody asks you, hey, is your sample different from 200 or 250, whatever the number might be. And here we use the ACT scores, and you have the choice here between these 3 years. I did it for all these examples, and then we also have the California ACT, means this is national, this is California. And I'm going to show it with one example. It's always going to be the same. So you see here the mean and the standard error. We use 24, and then the standard error is this term here. That's the standard deviation divided by the square root of n. And the mean difference is the population, the mean of the sample minus the population, right? And then the t calculated is this whole formula here, so it's the difference of the sample, the mean difference between the sample and the population divided by the standard deviation right here divided by the square root of n right here. So that's how you get the calculated t-value. Then you have two choices. Either you go the p-value route, you calculate the p-value. Here we use this function in Excel, tdist, then in parentheses the t-value that you calculate, so the t-value here, and then the degrees of freedom. Degrees of freedom, you get those by doing n minus 1. Then you get the choice between the tails, either 2 for 2 tails or 1 for 1 tailed. Here this is the 2-tailed value. So this will be the first thing you can interpret. Well, this p-value is this smaller than the critical significance level. If it is smaller, then we reject the null. If it is bigger, we retain the null. And the critical significance value can be 5% or 1% or 0.01%, 0.1%. So those are the conventional levels in social sciences. The other route will be to calculate t-critical. Also here, the Excel has a formula, t-inv, then the probability. You get to specify that. Here I said 0.05, the 5% level, and then degrees of freedom. So this here is based on the t-distribution. So based on your degrees of freedom, you get a different curve. And then based on this probability, Excel will tell you what is the critical t-value for this probability. Then the conclusion here, yes, because the p-value is smaller than 0.05, so we reject the null. And thus we talk about a statistically significant result. And for the other values here, it's exactly the same thing, same principle. I want to show you quickly how you do the real statistics tool, how you use that. So you can't see it because it's outside of the screen recording, but if you have a Mac, it should be on the very right of your menu on top. You click on the real statistics, data analysis tool. You should have this window that pops up. And now to do the t-test, again we got to tell the range, B2 through B21. Those are the names of the cells. And then we don't want the column heading included with the data. And then here we have to indicate which population mean we want. So I'm going to use the 21.1, the national average of 2012. And I'm going to hit one sample t-test and I hit OK. And now here we get the table. You can see the group mean is 24.75, standard deviation 5.18. Right, all this was done automatically. Standard 1.16. Right, all these corresponds. T-value 3.14. Right, this is the same as here. Here it's rounded. So let's see if we're exact. Let's go right here. Yes, we have the exact same number. And then degrees of freedom 19, and we get a p-value of 0.0026, right? And then we get a p-value here, two-tailed, of 0.005. So here we have the two-tailed value. Yes, we can see this, it's a two-tailed.